reactions. What does precipitation mean? Okay, when we're talking about precipitation, we mean something's falling from the sky, right? Rain, snow, sleet. For chemical reactions, when we have precipitation, that means a solid is produced in a reaction. Okay, so two liquids produces a solid. And that would precipitate, wouldn't it? Wouldn't a solid tend to settle out of a liquid? I'll show you a demonstration of that in a minute. So in a precipitation reaction is when a solid settles out of the solution. How do you know if a solid is formed? Well, you need to look in your book on page 125. There is a table called a solubility table. And if you don't have a book, you need to look on with somebody because you are going to need to look at the solubility table. List soluble stuff, table 4.2. Soluble means it dissolves in water. If something is soluble, then we would put AQ on it. Table 4.3 lists compounds that are insoluble in water. And if something is insoluble in water, then we would designate that by putting a little S on it. Because that means when I put it in water, it stays as a solid. So let me show you how to write a precipitation reaction. I'm going to give you the reactants. Potassium iodide, oh, I so misspelled that. Potassium iodide and lead 2 nitrate. Those are your reactants. So y'all should be able real quick like to tell me what those formulas are. What's the formula for potassium iodide? Ki. What is the formula for lead 2 nitrate? PbNO32. And now, y'all should be able to go to table 4.2 and 4.3 and tell me what goes in the parentheses here. What happens to Ki? Does it dissolve in solution? Yes, it does. So I put an AQ here. Lead 2 nitrate, does that dissolve in solution? Yes, it does. So I put an AQ here. Any questions on that? It's aqueous because all nitrates are soluble. There's no exception to nitrate solubility. Okay? The exception you see on that table, it's straight across from the chlorides, bromides, and iodides only. Yes, it's just for the one it's straight across from. Okay, this is a precipitation reaction, sometimes called a double exchange reaction. Have y'all heard that term before? Or an exchange reaction. If you took high school chemistry, you probably talked about these. How do you come up with the products of this reaction? You take the cations. What is the cation in potassium iodide? The potassium ion. What's the cation in lead 2 nitrate? The lead 2. The cations are always written first. The cations are the positives. Okay? You take the cations, the potassium and the lead, and you let them swap places. They exchange places. So the potassium and the lead, I'm going to flip-flop them, and the lead is going to be with the iodide, and the potassium is going to be with the nitrate. Can you write the products of that reaction? Say what? You're right. Very close. PbI2, because you still got to swap and drop. And what's the other product? KNO3. It does not matter if you write the KNO3 first and the PBI2 second. That's not going to matter.
The 2 go with the PB, right?
Right. The 2 on the I is because the lead had a +2 charge, and it still has that +2 charge. So now what do you guys need to do? You need to decide what goes in those parentheses. So you need to look at table 4.2 and 4.3. PBI2 is a solid, and potassium nitrate is aqueous. Am I finished with that? No.
So why did you switch the PB and the K?
That's how you do products for a precipitation reaction. You take the cations and you exchange them. And that's how you know what the products are. Okay? We're going to do a couple more of these. That's not balanced. How do you balance that? Can y'all do it real fast? Are y'all getting really good at balancing? I hope so.
You have to put a 2 in front of potassium, right?
The 2 on the Ki and the 2 on the KNO3 will balance it, yes? We're going to take this equation, now that y'all have seen it actually happening in the beaker, I'll leave the beaker sitting up here a little bit and then I'll show you as it settles out. All this stuff that we wrote is aqueous, we know those are electrolytes, don't we? And we know that in those beakers it exists as ions. So that means that Ki aqueous is really 2 potassium ions aqueous and 2 iodide ions aqueous. Agree with me? Lead 2 nitrate. What are you going to do with that? It's aqueous, right? So doesn't that mean that there are lead ions aqueous and 2 nitrate ions aqueous? And that takes care of the reactant side of the equation. Now I'm running out of room, so I'm going to draw the arrow and I'm going to put the products underneath. Okay? Letting y'all know that now so we don't get confused.
Why are there 2 nitrate?
Why is there a 2 in front of the nitrate? Because there's 2 nitrates here in the formula. The 2 from this formula, I have to incorporate it down here when I write 2 nitrates. Okay? Kind of okay? The same thing's going to, well, it's not going to happen over here. We'll do some more examples in a little bit, and I'll show you more of that. The products, guys, PBI2, that is this solid yellow stuff in the beaker. So the solids are not broken apart as ions. It's a solid in that beaker. So I leave it alone when I'm writing this equation like this. I'm just going to write PBI2 solid. The only things that we break apart as ions are the things that have an AQ designation on them. That's the only stuff we're going to break down. What would you do with the final product, the KNO3? Do y'all see that it would be 2 potassium ions aqueous plus, go ahead, Timothy, plus 2 nitrate ions. Yes, got to put the 2 because I'm taking the coefficient and distributing it throughout the KNO3. All right? This is called a complete ionic equation. That's a complete ionic equation, and it's complete because it contains everything in it that our original equation had. Now look at it. Do you guys see that there's some stuff in that complete ionic equation that's on the left side, and the same exact stuff is on the right side? What are you talking about? Well, do you see that the left side of the equation has 2 potassium ions aqueous? And the right side of the equation also has 2 potassium ions aqueous, doesn't it? Do you see any other stuff that's the same on both sides of the equation? There's 2 nitrate ions aqueous and 2 nitrate ions aqueous. And that's it. That's the only things that we see on both sides of the equation. Agree with me? So what are those things called? Those things that I've circled in red are called spectator ions. So when I cancel out the spectator ions, I'm going to bring down whatever I have left, and I'm going to write that. What is left? There are lead 2 ions left over. There are iodide ions left over. And then the only thing left on the product side of the equation is PbI2. And that is called a net ionic equation.
So all this is one problem right
Yes, we've just steadily been adding to it. We're going to practice another one now that y'all got the hang of it. I'll show you one example and you're good.